Hello?
What's up? What's
Hey, how's it
up?
going?
How you doing?
Going good. How about you?
I'm good. I'm good. You ready to do a mock right on the stream? How much people you got on here?
Yeah, let's do it.
All right. How
I
good are
came
you?
across your channel
Nice.
yesterday.
Sick.
I been watching some of your videos. I found it pretty interesting.
Nice. Which video did you first come across?
I came across the video where you're doing a
Oh, I see. I see.
meta
Nice.
mock interview. Yeah,
Nice. Yeah, that one's popping off.
that one is yeah.
How are your elite code skills? What do you think? What would you give yourself? Or how many elite code questions have you done?
My lead code skills. I would probably. I'm not the greatest. I I can probably do mediums comfortably.
I
I've
see.
done a couple of hards, maybe
Nice.
like four.
I see. Okay. I think we should
Yeah.
be good then. Let's just get into it. Let me send
Okay.
you a link. One sec. Did my stream cut out? Are you good? Can you hear me?
Mm-hmm.
Okay, okay, okay. The stream is
I'm
good
a
or what?
Berkeley student. So you can probably put that.
You go to Berkeley too?
Uh,
I had a
yeah,
couple
you can
Berkeley
make a
kids on
video. I
there.
don't know. Huh?
You're like the second Berkeley. Did you see my other one when I had the other Berkeley guy come on?
Oh, you were reviewing his resume? And you
Yeah, you
couldn't
saw.
get it? Yeah, I saw that video.
Bro, I work with a lot of Berkeley kids. Okay, let's run this though. You're probably good then. Let's see.
We'll see. I don't think so.
Um, Let me figure out. There's a way to share on LeetCode Premium. There's a way to share who's, or there's a way to share interviews. Let's see, interview online. Wait, no.
Yeah, it should be. There's an interview tab right there. Yeah.
Let's see, what's this assessment? No, it's not. So what is this online interview? And I could interview you.
Mm-hmm.
Nice. That's cool. So what year are you in?
I already graduated.
Oh, nice, nice. So you're looking for
Yeah.
full time?
Mm-hmm.
Are
Yeah,
you
I just
already
started.
working though?
No, I already started the job hunt, and
How is it?
it's a lot better than before. Actually, I've been getting a lot of OAs.
Nice.
I've been passing a lot of the OAs, and I think main thing for me is just the behavior.
I see.
Yeah,
Okay.
I feel I prep too much for the tech that I forget like to prep for like given a situation, what would you do type question.
I feel like those don't weigh that heavy though. I don't know. From your experience, you think they weigh heavy?
I mean like if you're like stuttering
Mm-hmm.
like how I usually do, then like it's gonna weigh a lot. I feel like I stutter too much and I get like too nervous.
I see. Did you join the interview or what's happening here? How do you do this?
You gotta send me a link.
Wait, give it a sec. It's lagging. Tweaking out. Okay, wait. How do you do this? Created. Okay, wait. Okay. Let me send you a link.
Okay.
I'm gonna send it to you on. Let me add you quick. Give me a sec. Okay, I sent it to you. I sent it to you. Okay, I'm gonna find you a good question. Let's see. You done all the classic questions?
Maybe. I
Alright.
think so. Um, yeah, let's see.
Yeah, let's see.
Let's see. Just give me one and I'll tell you if I know it or not.
Sounds good. We'll keep it to about like 25 minutes a question. We'll see if we go like one or two. If you do it fast enough, we'll go on to another one.
Sounds good.
Did you grow up out here in the Bay?
No, I grew up in Florida.
Oh, nice, nice. You just came out here for school at Berkeley?
I did like my senior year of high school to get in-state tuition, and then I transferred to
Nice.
community college, and then I did.
I see, I see. Alright, let's get it. This should be fun. Let me think.
Let's do it. It's exciting.
Valid word. You're in?
Did you send me a link in? It's in the general chat.
No, I sent you a direct message.
Oh, I see. Okay, yeah, I'm joining right now.
Yes, sir. A's
Okay,
asking.
you see me?
Wait, let me just check how my stream if my stream is live. You're in? Oh, nice, nice, nice. What language do you like to do your interviews in?
Let's do it in Python.
You want to do it in Python? Sounds good. One sec, I'm just verifying my stream. Yo, stream, put a thumbs up if everything looks good. I'll verify this too. Hold on. I'll verify this too. Wait, let me rewind. Alright, perfect, perfect. Let's get it. Alright. Let me look for a good question. So let's go with what are your strong languages? Or sorry, questions like arrays and stuff like that, or what?
My strong suit would probably be like graphs, trees.
Graph trees. Okay, okay, sounds good. Let's do.
Also like double pointers and windows type
Okay,
stuff.
sounds good. All right. Okay, let me give you this question. Oh no, this is a premium. I don't want to do no premiums right now. We're gonna do everything on the whiteboard on this editor to simulate a real interview. I'll just copy in the prompt, and then you have to work through it and get the test cases going. And yeah, get it. Basically, write good code, and we want to focus on working code that covers all edge cases. How's that sound?
Yeah, that sounds good.
Okay, for warm up, we're gonna start off with this question, and I'm gonna drop it in real quick. So I'll quickly tell you what it is. So we're given a string S. Return true if S can be a palindrome after deleting at most one character from it. So this is the first example. This is the second example. This is the third example. Cool.
Okay. Okay, let's see how I would approach this problem. So I know you can quickly check a palindrome in O of n just by checking the first and the last, and if they're equal, then you just move on to the inner string and keep checking that until you reach the middle. But if you need to switch at most one character, then let's see. Let's take this for example. Example 2. And let's simulate starting from the front and the end. So the two ends match together, so we'll move left forward and right back.
Yep.
And B and C do not match, so we can remove C. But how do we know that? We can either move B or C, and then it'll be a palindrome. Okay.
Makes sense so far. Lev, what's up? And I'll be responding to the chat at the same time. It's gonna be if I'm saying anything, this is not representative of a real interview. In a real interview, I probably wouldn't be saying anything, but see what the chat is saying. Lev, what's good? How's everyone thinking about his approach so far? So okay, you know how to check a valid palindrome. I like that. And then once you see an issue, you're trying to see which one to delete.
Yeah.
All right, I'll let you think for a bit.
Okay. Let's see if like the string has more inner characters. Like this. Okay, so say we have this string.
Yep.
Then we can remove C and it'll be a palindrome, but if we remove C, then the next one has to match with B. And furthermore, all of the others have to match. So we can just after we see a letter don't match, we can
Mhm.
remove it and then check if all the other letters match. And if they don't, then we'll just say that we'll just return false. Otherwise, we'll return true. Does that approach make sense so far?
Yeah, it makes sense. But could you be more specific on what you mean by deleting the character?
Yeah. So say we have this string over here. When we start at the front and back,
Yep.
we'll see that both A's match, and
Mm.
then we'll get to a case where B and C don't match.
Yep.
Um, we can either remove B or C. We'll try removing both. So we'll remove B first and check that A doesn't match with C.
Mm-hmm.
Okay.
Sure.
So we'll so after we check this, now we'll check the other side and see if we can do the same thing. So we'll remove C and then check that. Okay, now the B's match, the A's match on both sides, and the inner C's match.
Nice.
I will just do like a regular check palindrome.
Mm-hmm. Okay. I like that
By
approach.
first trying the left and then the right.
Yeah, your approach makes sense to me.
Okay,
Go ahead and code it.
let's start with coding. So we're gonna start with left is at 0, right is at. So we'll say well, actually, let's just define a function first.
Sure.
Check palindrome version 2, I guess, and then it takes a string. Okay. So we'll check the left and the right.
While the left is equal to right.
Yeah. Let's put this condition first. So we'll continue checking the left and the right until we get to a case where the characters don't match.
Mm-hmm.
And then we'll return. Sorry, we're not gonna return. We're gonna exit this while loop. And then now we're gonna try deleting the left character. And then we're gonna try deleting the right character.
Sure.
And that's how we're going to do it. So let's try deleting the left character first. So we'll move just to delete it. We'll just move the left forward. Let's keep a variable to remember where left was. We'll just call it OG left,
Sounds good.
and then we're gonna move left by 1, and then we're gonna check.
Alright, if it was a real interview, what would you name it? Just to make sure our habits are good.
Okay.
Because for the stream, yeah, that's a nice variable name, but I don't want to set you up for accidentally pulling that out on an interview.
Okay, maybe like prev L.
Mm-hmm.
Okay. So while the left is less than the right, return true, and then we'll say if the reason why we finished, the left and right cross each other, then we know it's a palindrome. So if L is greater than or equal to R, return true. Otherwise, we know that
I'm gonna run.
we
E,
failed that.
it's over here. Just keep going. E is asking what the question is. It's valid palindrome, but delete at most one character. So verify that if you delete one character, it becomes a valid palindrome. Yo, send it in the chat. Keep writing, keep writing. You're doing good.
Okay. So this does exactly what I think I described. Okay, wait. This is supposed to be -1.
All right, it's getting. I think that we're duplicating too much code here. That's that's the one feedback I would give right away. Is there a way that we can clean it up first, or do it more in a cleaner manner?
I can probably write a function check palindrome where I just have this loop and give it a
Yeah.
start and an end index.
I mean, let's just go with this, and if we run into bugs, then we'll fix it. But let's just see if you're able to implement it without any bugs.
Okay. Um, could I give it some test cases?
Yeah, for sure. Definitely. In the interview, they're going to make you run some test cases on it. So, but just walk me through line by line what's happening, and let's see if we can see if there's any issues with it.
Okay. So I have a pointer left and right that I start at both ends, and I try to increment the move the left forward and the right back, while the characters are equal.
Mm-hmm.
And oh, actually, I should check if left and right crossed each other here. So if left is greater than right, then we know that we've checked the entire string and
Sure.
we'll return true. Yeah, there's a lot of duplicated code.
Yeah.
Um, so if we exit from this loop, it's either because left crossed the right, or we found a character that is not equal to the other character. And if this is the case, we'll try deleting the character from the left side, and if that doesn't work, we'll try deleting the character from the right side.
Yeah.
And
Makes
then, and
sense.
if after trying both sides, then there's no way that the string can be a palindrome.
Yep. That makes sense. That makes sense. Okay.
Okay.
Walk me through this part right here. Is will this work as expected? This try left part that you're mentioning.
Let's see. So so we're gonna store where the left was, just so we can get back, just so we can put back the left pointer after deleting the left character, and then we're gonna increment it to simulate removing it from the string, and then we'll do the same exact check as above. And same thing, if we exited from this loop, it's either this condition or this condition.
Okay.
And if the left and the right cross each other, then we've checked the entire string and it's a palindrome.
All right.
Otherwise, we'll reset L back to what it was initially, and then try deleting from the right side.
Yep.
So
That makes sense. Okay.
to me, this looks like it should work.
All right. Let's run it on some test cases and see and verify that it works. We have 3 examples up there.
Okay, so let me just run it on the very first example.
So Squagmire saying, is there a solution? Oh, sorry, it's repeating. Someone jumped in. Squagmire saying, is there a solution that leverages the string odd or even numbers? Okay, my bad. They're saying I'm blocking the code. Hold up. Let me switch this over to this side then. You're right. Hold on, then I'm blocking the chat. Let me sec. Let me fix this up. Oh, it's all good. You can block the chat.
Okay, so it looked like it worked on the test cases.
Let's see. You ran it? Let me see. Let me zoom in. Okay, let's run this code. So it worked on ABA. It worked on ABC. Okay, let me verify.
I'm gonna clean it up while you're doing that.
I mean, I can move this. Let me move the chat because people are saying, "Are you in the chat?" I can move myself to the left. Give me a sec. That's easy. Yeah. There you go. I'm not convinced that's gonna work at all test cases. Let me read over it again though.
Okay.
It's going crazy. Try deleting the left character. So we take L, we store L, but L here has already moved, hasn't it? Okay, L. Okay, we get to the first place that's a mismatch, right? So we store the old L and we move one up, and then okay, we keep at our right. That makes sense. We move our right until they're the same. Oh, sorry. We start moving our right here, right? But previous R equals. So when we try to delete the first character, shouldn't we go back to the first character that was mismatched? So for example, or go ahead.
Yeah, could you explain what you mean?
So you said that pretend we mismatch on A, B, C right here.
Yeah, see?
Right. We did a mismatch here. And then you want to try deleting R first by moving this up, right?
Yeah.
And then you also want to try deleting C by moving this up, right? By one. So is R actually in the right place right there when you're doing this one?
I see what you're saying, and you're very right. I don't store the previous R. So I need to actually store R as well. And then reset both of them.
Yeah, then I think it would work. The edge case is a little small, so it worked for that, but I mean, let's throw this code into the lead code and see if it actually runs. One sec. Where's the chat? What's everyone saying in the chat? Studio. Okay, maybe, yeah. Is there a solution to leverage this string and odd? Can this be done recursively? Let's see. We'll clean it up after. Don't worry, Coach Mo. Let's see. So we're gonna go this. Paul, why do you say it's not optimal? It works. It works. It could be a bit cleaned up. And are you watching my stream right now? Are you on my stream or are you looking at the?
Me?
Oh yeah.
Yeah, I'm watching. I just got on your stream. Okay. Did it work fully?
What? I think it's good. It's good. What I would ask is now, what could you do, since we still have a couple minutes left? What would you do to clean it up?
I began by just defining this function check palindrome because I do this 3 times.
Yeah.
One here, and then I can just call this function.
Okay.
And
let's run it.
I will do it that way. Yeah. And actually, with this function, I wouldn't need to store a previous L, previous R. It would just change internally.
Sure.
I can try cleaning it up right now.
Yeah. Let's spend about 2 minutes, but try to do it fast so we can move on to the next question.
Okay.
No, good job though. You walked me through the thought process, able to come up with an optimal solution. To me, that's optimal. Paul, I think the optimal is pretty much what he did, because you don't know which one you should delete. You have to pick. You have to try deleting either one or the other. But overall, I think it looks good. At the end of the day, it's still ov n time complexity and ov n or ov1 space, no extra space, just pointers.
Okay. I think this is what I'll do to clean it up.
Yeah, it looks good. Go like, and even like just throw it down here like this.
Yeah, it's even better.
Let's see if we run this. Yeah, it looks good. Let's go to the next question. Let's step it up a notch. Yeah, good job. Let's see.
Thank you.
Let me think. All right. Let's see. Hopefully this one's not a premium question. Shit, it's premium. All right. You've done the lowest common ancestor questions or no?
No, I have not done that.
Oh, you never done the lowest common ancestor question? All right.
I worked on it, but I just gave up.
Okay. Let's not do it then if you've already seen it. So, let me think. Let me find a good one. Okay, I got one for you. Actually, this one requires a bit of... The thing with working on the trees one is we can't just do it on the editor like this. Actually, we can. Because we can assume that we're just given nodes. I've done ones that require trees as well. Somebody said longest palindromic substring. I don't know. We just did a palindrome question. I kind of want to move into a... Okay, I'm going to give you this one.
Okay.
Have you done 543 on LeetCode? Try it out. Try looking it up if you did that yet.
Let me see. No.
You haven't done that one?
I haven't done that one, no.
Alright. Okay. Let me drop this one in the chat or in here. Job on the first question.
Thank you.
I'd give you 3 out of 4. A 4 would be if you did it optimally, which is good. Because usually when we do ratings, we give candidates 1, 2, 3, or 4. Usually we'll give a 2 if we had to give so much hints in order for you to solve it. If you can't even solve it and you can't even code, I would give you a 1. But since you're able to solve it, I'll give you a 3. But the code was a little messy. And I think you could have moved it a little bit faster. But that's sort of... Because if you already know the answer, I might as well code it up fast kind of thing. But that's just preference, honestly. I think you did good.
Thank you.
For a new grad position, that's good.
What do you think about my explanation?
Yeah, I think your explanation is good because you looked to solve the problem and you went all the way up until you found what was breaking, which was... Oh, sorry, something's ringing in the back.
Yeah.
But yeah, I think it's your explanation is good because you knew exactly what to do, which was try both cases. So I don't know, no problems with there. I think you did good. Okay, let's move on to this next question.
Okay, let's do it.
Yeah, but like honestly, if you're for a senior or something like that or staff, they should. I've been at companies where they're like, if the person doesn't solve the first part within 20 minutes, it's a fail.
Oof.
But I think for new grad position, they don't do that. I don't really like doing that way either. For me, it's more if they need to solve as long as if I'm gonna ask 2 questions, they solve it. But some people track for speed. Honestly, that's what I've seen, especially in the Bay. Okay, take a look at this one.
Okay. So given the root of a binary tree, return the length of the diameter of a tree. The diameter of a binary tree is the length of the longest path between any 2 nodes in a tree. This path may or may not pass through the root.
I hope you're all here with a diagram. What are you thinking? Madi, which tree question are you talking about? Distance K from the target? It's a good question. Did you do that question yet?
Distance K from target?
Oh, this is good. This is a good one. Anyways. Just keep going with this one. Somebody in the chat was wanted you to do a different question, but I think this is good. All right.
Okay. So for this input, I'm going to say the longest path is from 4 to 3 or from 5 to 3. It can either be 4 to 3 or 5 to 3, right?
Yeah, exactly. And basically, the path is the number of edges between them. So you see, there's 3 edges, so it should be 3.
Okay. Let me think about this.
You already,
my
yeah,
first
exactly.
idea- The first idea is just there's an algorithm called Floyd-Warshall. I think it gives you the distance to all pairs,
Distance to all
all
pairs.
all node pairs in a graph, but I think that might be overkill.
Sounds like it. Sounds overkill.
Yeah, the runtime of that algorithm is O of n cubed, I think.
Okay, we're looking for a faster algorithm than that.
How would I do this?
So what are you thinking so far? Just want to get a pulse on what are some of the solutions that are going through your head.
Probably DFS. I'm thinking to do some sort of DFS. And maybe even some dynamic programming.
Why are you thinking of those approaches?
Let's see. Well, let me try to get the solution for this by doing a walkthrough. So
Sure.
we'll start at root. Sorry, what would be the input? It would just be the root node, right?
It would be the root node, and then you just return a number. So your function
Okay.
definition should be something like given a root, then return a string.
Got it. And let's see how we would do it for this. So root, it would go down to 2, and it would go down to 4. Then we'd go down to 5, and then we'll go back to the right side. Okay.
So you're doing a post order, in order, because with a lot of these tree questions, it kind of
Yeah.
matters if you're gonna do a post order traversal or in order or pre order.
Post order is like when you visit all of its children, then visit itself, right?
Yep, exactly.
Okay. Well, DFS is post order then, right?
It depends. You can write a DFS and it's gonna be a pre order, in order, or post order.
Right. Okay. Yeah. This question might have stumped me.
I can give you a slight hint. That's no problem. So, are you familiar with pre-orders, in orders, and so pre-order is pretty much when you visit the node.
Yeah.
And if you read Cracking the Coding interview, this is probably the first thing that they'll drop right away inside of the book is when you're doing a DFS, you could do it in 3 ways. A pre-order, visit the node, visit left, visit right. And Stoner is giving a hint. Think about the case if you add 6 and 7 after 4 and 5 respectively. Think about if you add. I don't get the case. So pre-order, visit the node, visit left, and visit right. In order, in the in order case, you visit the left, you visit the node, and you visit the right. And in the post order case, And maybe if you're stumped, I can walk you through how I would do it, and then I could ask you a different question. But just to explain the techniques. So post order would be you visit left, you visit right, then you visit the node at the end.
I see. I think I may have a light bulb may have clicked.
Nice.
So the diameter is for sure going to be on separate on like the left and a right child. Actually, it might be okay. What if like we calculate the length of the left tree, the height of the left tree,
Mm-hmm.
and the height of the right tree, and then add those together?
Okay.
Because that would be so like the height of the left subtree rooted at a
Mhm.
sorry rooted at 1,
Mhm.
it's 2.
Yeah.
It's 2, and the height of the right subtree rooted at 1 is 1.
Sure.
Just the maximum height of the left and the right summed up will give you like the longest path, because yeah, it will give you the longest path.
Mm-hmm. Yeah, that makes sense. So walk me through. So when you're here, what would you do? So you're gonna run that on every single node. How
Yeah.
would you calculate that?
So I'll keep like an answer, like this is what I'll return above,
Mhm.
and at each node, I'm gonna just update answer. Answer height of left plus height of right, and then I'll do it that way. And then at the end, I'm gonna return my answer. So I'm gonna write a function that gives me the height
Okay.
of of a subtree.
So if I'm interpreting this properly, we're gonna start at the root node. We're gonna calculate the height of our left and the height of our right by
Yeah.
some sort of depth first search, and then we move
Yes.
on to the next, and then we calculate the answer, and then we move
Mhm.
on to this one,
Yeah.
right? Okay, that makes sense, and I think it'll work. But what would be your time complexity?
If there is n nodes in the tree, we'll visit every single node, and calculating the height is just an O of 1 operation. So it would be O of n.
Is calculating the height of n? You said at each node you're gonna perform a depth first search.
Yeah.
Here, right? So if I had to do, so how many depth first searches am I running if I'm gonna do it on each node?
So you're gonna visit this node, and then visit this node, and visit this node and get the height of the left and the right.
Mm-hmm.
And then using these results, you're gonna 2 is gonna get the height of, and then two is gonna get the height of the left and the right, and then you're gonna visit each node at most once. You're not gonna visit multiple times.
Okay. I see. I was thinking, because you initially said you're gonna perform a depth first search on every single node.
I see. Yeah, I mean, just like passing. Yeah, I mean, you are technically, right? Yeah.
Yeah. So
you
down
do a
here,
depth-
if you look
Yeah.
at these three cases, which one are you gonna do? A pre-order, an in-order, or post order?
I'm gonna visit the left and the right, and then use their heights to calculate my answer.
Nice. Yeah, that makes sense.
I'm not sure which one that would be. That would probably be visit left. Okay, yeah, post order then.
Yeah. So yeah, do you think it would be able to be done with a pre-order, in-order, or post-order is most optimal for here?
Pre-order would visit the node, then visit the left and the right. Visiting the node would mean that, well, I mean, like, to calculate the height of our node, we have to first know the height of our left and the right. So we have to first visit the left and the right subtree. So I don't think this one could work. Maybe like if we do some weird code, but
Yeah. 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 My point is, yeah, like you're seeing why it kind of matters if you're going to do a pre-order, in-order, post-order, right?
yeah.
Yeah, exactly. So nice. That's a good thing to know because for me, when I do some of these graph questions, I make sure to think about, okay, when do I like for this one, we kind of want to know the results when we're visiting a node. Like you mentioned, we want to know what happened in our left child, what happened in our right child, and then use what happened there to figure out our result. So I think the best way to do those is usually a post order traversal.
Right.
And when you start working with things like binary search trees, you're gonna have to do in order traversals because in order traversal lets you visit all the nodes in the proper order. That's why it's called in order. And then pre-order is just if you want to do a regular DFS kind of thing. But these are small distinctions, and I feel like not a lot of people talk about it. But I think for me, it's important to know the variations that I have.
Right.
Yeah. Okay. Cool. Go ahead and implement that.
Okay, so I'm gonna define a function tree diameter, and basically we're gonna have this variable called answer, and we're gonna call DFS from the root, and answer should update this global variable, and then we'll just return answer.
Sure.
So let's define this DFS function. We'll call it node. Well, first, if root is null, then just okay. So let me just say what this this is gonna do. This is gonna return the height of the tree rooted at this node. Yeah, height of the tree rooted at this node. This is what DFS will return. So if it's null, then we'll just return 0. Otherwise, we'll just return 1 plus 1 plus
Let's just
whichever
pull
tree
that
is
out.
bigger, either left or the right.
Sorry, almost cut you off. But let's just pull it out into its own function just to keep it clean, because we could just have a separate move that function out.
I was gonna use like
I see.
non-local.
I see. Okay. Yeah. Go ahead then.
Okay. So we'll take the max of the left and the right, and that would be the height of our tree, whichever is longer, the left subtree or the right subtree. So we'll calculate the left height. And then we'll also calculate the right height.
Sounds good.
Okay. And then after this is how we're gonna update answer. Let me just copy what I wrote above. Okay, and I think, let me just think about it. Yeah, I think this should work. This is what I implement. This is what I basically described.
Okay, so we're given a root, we're given node, and we're seeing. So the answer is saying non-local. If not node, return 0. Noor, what's up? Then we go to left height, dfs.left, dfs right. Answer equals left plus right. Yep, makes sense. And then we return 1 plus the max of the left and right.
Mm-hmm.
Yeah, looks good to me. Let's try running it in the code.
Yeah.
Nice, good job.
Thank you.
See, where are we at? Okay, we need to push this in. Nice, good job. Yeah, giving you I would still give a pass because you took the hint really good. But
Thank you.
yeah, I'll give you a pass, especially for the new grad position. I didn't give you too much of a hint. I think mostly what I did was I just started listing out these traversals and then it clicked. Some guy said, "Glad I'm in med school because coding
Yeah.
makes no sense." No, good job. I'm good. Your skills are good. I'll just keep practicing more lead code. I think you know
Thank you
what
so
you're
much.
doing. Yeah, I think you're good.
Thank you so much. I appreciate it. I'm gonna head out for tonight.
Yeah,
I
no
hope you have a
problem.
good night.
Good job. Good job. What's
Yeah.
everyone giving him in the chat?
Yeah. Let me
All
see
right,
what
I'll
they.
catch you.
See you. See you.
What's everyone giving him in the chat? Hired? Great work. Nice. Let me move this. Let me fix my OBS. Should we grind more leak code questions or what? Moderate higher? Javante in the building. Let's get it. Yeah, that was good. Should we solve some more leak code questions or should we hop into some system design? Google guy, what's up? Yeah, strong hire for me is cracked. Strong. So what do y'all want to do? Let me know if y'all want to do system design. Let me just hop through my system design notes. See who's familiar. I'm just gonna read through some of my system design notes and see what people are saying. So I have this big list of system design notes. And sorry, let me move myself off this thing. Move yourself right here. Yeah, these are my notes. These are the notes that I would use in order to study for my interviews. So I pretty much compiled these notes from a few books. Dude, my Notion's tweaking. Wait. Let me restart my Notion. Let's end this here. See how much leak code questions this guy did. Where is he? Yeah, let's run into some. Let's do some system design just so y'all know what's up.